everyone. I hope you've been having a good weekend. Looking forward to next week of distance learning. I had a question come through about homework 1, question number 9, the table of levers. So basically what we have in each of these questions, we have a lever. There's going to be some fulcrum at some point. And we have forces or objects on each side of the lever. So basically our table is broken into 2 pieces. I'll do that with yellow here. And while it's not stated, which might be part of the reason some people are having a little bit of confusion, what I'm looking for is this torque on this side should be equal to the torque on that side. I'm trying to balance everything out. So one of the first things I can do, so if I want to find torque, torque is equal to force times the distance of the lever arm. In this case, we're labeling that as R. Okay, so actually I'll change mine to R. So in this case, our distance is labeled as R. And on this side, which I'll draw in blue, again, torque is equal to force times our distance, the radius of our lever here. Alright, so in order to find torque, I need to know force. Well, my next column over here is force. How can I find force? Well, one of the ways force is mass times acceleration. Okay, a specific form of that force is mass times acceleration due to gravity, which we label as g. And just while we're at it here, another way I can solve for force is going to equal torque divided by the radius. Okay, I'm just manipulating the formula for torque here to find force. Okay, and that applies for both sides. So again, force is, oops, wrong spot. Force is mass equals mass times acceleration, or mass times gravity, or force equals torque divided by the distance, the radius. So in a lot of our problems here, I am given mass, and I'm given acceleration due to gravity. I can just multiply those together and get force. So let's go through and do the first one. 9.8 times 12 gives me 118 newtons. Okay, I got 117.6. I'm going to round to 3 sig figs, 118. So now if I want to find torque, torque becomes our force times our distance. So 118 times 20, 2,360. Now I don't state what units we're using here. This could be centimeters. It could be kilometers, but just for simplicity's sake, I'm just going to say it's meters, and then I don't have to do any converting. Okay, so now I know this torque needs to equal that torque. So this is going to be 2360 again. And for force, it's mass times acceleration. I should change the color here. 2360 should be in blue for this side. 2360. Okay, force, mass times acceleration. So 25 times 9.8 gives me 245. So now over here, my blank is the radius. R is going to equal, well, I can use this torque. R is equal to torque divided by force. So my torque, 2360 divided by my force, 245. I end up with a radius here of 9.63. And so again, it's not stated, but I'm just saying my radius is in meters, my mass is in kilograms, my gravity is in meters per second squared, forces in newtons and torque is in Newton meters. I can write that better. Torque is in Newton meters. So that's that one. The next one is the exact same layout, so I'll do the same process. But let's get down here where I don't have the radius on this side. Okay, so I can still do my force. So 14 times 9.8. I get a force of 137 newtons. But I can't find my torque because I don't know my radius. But if I flip over to this side, I can find my force. 26 times 9.8. So I get a force of 255 newtons. And here I can find the torque because I have 255 and I'm given my radius of 32. So my torque here is going to be 8,160, which is going to equal the torque on the other side, 8,160. And then again, to find radius, radius is torque divided by the force. So 8160 divided by 137 gives me 59.56. So I'm going to say 59.6. Okay, and then the next one laid out the exact same way. Okay, this one, the third set down. Now I'm missing a mass over here. Well, I have all the information I need on this side, so we'll do that one first. Okay, force, 16 times 9.8. That gives me 157. And then to find torque, it's that 157 times the distance of 10. So 1570. And that is going to equal the torque on this side. Okay, so now that I have the torque, if I want to find force, force is torque divided by radius. So 1570 divided by my radius of 34 gives me 46.2 as my force. Well, here I want to find mass. Well, using FMA, or F equals mass times gravity, I can find mass as force divided by gravity. So 46.2 divided by my gravity, 9.8, gives me a mass of 4.71 kilograms. Alright, and then we'll just have this last one right down here. We are missing the mass on this side. We have everything on this other side, so it's basically the same over here. It's just reversed. So I'm going to start on the blue side. I can find my force, mass times gravity. 27 times 9.8 gives me 264.6. So I'm going to round that to 265. Okay, and then take that force, 265 times the radius, 36. I get 9,216, so I'm going to round that to 20. 9220, 3 sig figs. Okay, 9220 for my torque. On this side, it should be in red. 9220. Okay, so torque, I want to find the force. Force is torque divided by the radius or the distance. So 9220 divided by my radius of 30 equals 307.3, so I'll leave it at 307. Okay, and then I want to find mass. Mass is force divided by gravity. So I take my 307 and divide it by my 9.8. And I get 31.3. And then the last one is exactly the same, just with different numbers. So hopefully that can help you get through Table 1. I'll try to do one more. I'll do Table 3 next, the one from third homework. And then I'll go back and do the one from the second homework. I'll try to get those both done by tomorrow. Let me know if you have other questions. Have a good day.